Are we online? Can people hear us? Stop sharing. Okay. All right. Well, welcome to our local audience here at Tufts University and to our online audience, present and future. Welcome to the second of 3 digital classicist New England talks that will be held this week. On Monday, we heard about social network analysis and analyzing information about people and places. Today, we're going to hear about one of the other fundamental categories of data, which is linguistically annotated source text. So you might say peoples and places deal with the kinds of things that would show up in encyclopedias. Today, we're going to look at the kind of things that would show up in traditional grammars and dictionaries. But what we're going to see is the application of this kind of data when it is translated into a digital machine actionable form for reading and understanding historians. Now, the assumption here, and I think you'll probably talk about what tree banks are, but I'll just say that tree banks are an attempt to encode in a machine actionable form the kinds of questions that students have been tortured with for thousands of years. So I'm sure that Cicero was asked and probably beaten by his teachers saying, what is the main verb of this Greek sentence? Or what does this word depend upon here? And we've been answering these questions for a long time. Now, when we write down systematically the answer to the question of what is this word, what does it depend upon, and what is its function, we create a radically new kind of data source that is as close to the study of language as you can get to a genomic database. This is the foundation for the study of Greek and Latin. And we, in fact, have never really studied Greek and Latin, even though we've been working at it for 2,000 years. We're really at square one, re-establishing our knowledge of the language. And Bob and Vanessa are going to talk about applications of this beyond the merely linguistic space and the purely linguistic space and into our understanding of how people understand the past. Bob and Vanessa are long-term friends and colleagues from the University of Nebraska. Were in this building a couple of years ago for an NEH Institute for Advanced Technology and the Digital Humanities. And we see here the results of that initial work. So with great pleasure, I turn it over to you guys.
Thank you, Greg. I'm going to get us started today and then turn it over to Bob for the math. This is a project that we've been working on for a couple of years, sort of in and out. We've been working very closely, of course, with other people in this room and elsewhere, like Monica and Bridget and Gernot are 3 that I have to lift up as being incredibly helpful, and Greg, of course. But in a way, this is a huge collaborative project because none of it could be possible without the resources that are available through Perseus and Perseids, the Arethusa project, the Alpheus. What I'm going to say is going to be very basic for some of you, and I apologize, but I want to really pitch this for the people who know nothing, so that we start on the same page. And okay, let's come back here. Okay, now I can't get my my PowerPoint to go forward. What's going on? Here we go. There we go. This is part of the Digital Athenaeus project that Monica has spearheaded, but that we've kind of settled on this fairly obscure author to most classicists, but we think that he's one of the most critical authors in all of classical antiquity, because we've got a fundamental research question that we're asking, which is how accurate are the quotes, paraphrases, excerpts, and epitomes attributed to earlier authors, because they're the source of a lot of what we do in classics, and people tend to use them indiscriminately with things that are directly transmitted as if they are of the same quality. And the case in point, of course, with Athenaeus is huge because he's writing about this somewhere around 200 AD. We really don't know anything about him particularly, except he's from Naucratis. But he has this wise men at dinner, a quite lengthy 15 books dinner discussion, in which we have very many layers of text. We have words that Athenaeus himself are speaking. We have words of the 24 dinner conversants. And then we have something like 2,500 quotes or paraphrases from over 800 writers, most of which are not preserved elsewhere. And so we have all of these layers that are really hopelessly intertangled and that are being, again, treated as if they are the same quality. Now, Bob and I have been working together a long time, and our marriage remains intact, and I'd like to think stronger. It's hard to know. We've been working the old-fashioned method with computer-assisted philology, which is to say doing lots of word searches, looking at lots and lots of passages, looking at the micro-analysis of many passages to try to do good analyses of what words actually mean. And I'm thrilled to say that the result is out and done, and we don't have to, you know, it's in the flesh, as it were, now. In this book on corrupting luxury. And what we discovered there by applying close readings to all these passages is that many of the passages that are supposed to be quotes or paraphrases, we can make a pretty good case from the diction and the idiom used that the moral components of these passages were added by the later author. So Athenaeus added the moral component to what was otherwise a generic description of people's dress. And he's the one that said, oh, they were corrupted by their luxury. Here's an example, they wore these flowing robes. And so we make this case in our book that there's a lot of problems. But the question is then to do the next step forward is to do the macro analysis, to see if we can use, in our case, treebanking, to figure out who's writing what parts, to derive what we call syntactic thumbprints of the different writers. And this is kind of a complex process, and it's kind of beginning from scratch. So for example, the first thing we need to do is a database of syntactically analyzed prose, which is a huge project right there. Once we have the database, what we want to do is teach the computer to distinguish known authors. So if we plug in some Herodotus and plug in some Thucydides, can the computer tell us this is Herodotus and not Thucydides, and why? And then finally, to take this process and then compare directly transmitted prose from an author to epitomized prose of the same author. In other words, something that came to us straight compared to something that was quoted 10 centuries later, and see if that quote from 10 centuries later is really the original author, or whether it's been doctored so much you can't really say anything about it. So this is kind of where we're going with this. So for example, the two great test cases are Polybius and Diodorus. Polybius, who wrote in the 2nd century BCE, wrote 40 books. We have 5 of them directly transmitted, so we have this kind of baseline. But then there are bits and pieces of most of the others, mostly preserved in the 10th century AD. And the people treat them as if they are of equal validity. If they're all Polybius, it's exactly what he said, and they don't actually question the accuracy. And the same thing happens with Diodorus, also writing 1st century BC, has 15 books preserved, and others mainly are either in the same Constantine excerptors or else in Photius, but still very, very late. So this gives us sort of a second step. Once we can tell Herodotus from Thucydides, can we see if there's a difference between early Polybius and late Polybius? Then, and only then, I think, can we start looking at the fragments of the lost authors, which is a whole nother kettle of fish, because of course there's nothing to compare them to, but there is. Because we can compare them to fragments of the same authors that are preserved in other sources. There's lots of fragments of Timaeus. A handful are preserved in Athenaeus. Are the ones in Athenaeus comparable syntactically to the ones preserved elsewhere? Then we can compare it to Athenaeus himself the words that are not his quotes, but his narration or his Deipnosophists speaking. So the question becomes, which does it resemble? Does it look like the fragments of the same author that we find elsewhere, or does it look an awful lot like the author that is quoting it? So we can start making real data-driven judgments about the accuracy of these quotes. And so that's where we're going with it. Now, we're using this dependency syntax tree banking, and this is where most of you know what's going on, but I'll just say very briefly, it's based on corpus linguistics, which is the idea of taking real-world texts and deriving abstract rules from those texts. And it comes in sort of a three-step process. One is you have to annotate, which is creating the database that I was talking about, the Treebank database of syntactically analyzed prose. The second step is then to translate that into something the computer can search. And then finally, of course, analyzing what you get. So I'm going to talk about sort of the annotation very briefly, and then I'm going to hand it over to Bob for the abstraction and analysis. And also, just very briefly, we use dependency rather than constituency grammar because if for no other reason, dependency is a lot simpler. You can learn it in a few minutes as opposed to a semester in school. You don't have to keep multiplying elements, and it works a whole lot better on periodic sentences of Latin and Greek. Dependency grammar does. Constituency grammar is much better in English and word order driven languages. So we're using this. Of course, open source is a huge vital part of this. This is a huge collaboration. And what we're doing, we're hoping will spawn lots and lots of other projects. I mean, we keep thinking of projects in our head that we'll never get to. You know, we like to think that we're spawning dissertations like crazy. That's great. That's what we want to do. Now, there is already some material tree bank. This is a pretty old list. I know it's not up to date. But one thing you'll notice there's about, 370,000 tokens done. But you'll also notice, if you know your classics at all, that these are almost all poetry. And so the first step has been to make a data set. And so I've been working on this for a couple of years now. And you can see I've done almost 150,000 tokens at this point, most of which are accessible either through Monica through the Athenaeus website, or Bridget's put them up. And my goal here is to get good hunks of, say, 20 to 30,000 tokens of a representative sample of prose authors, so that we can then start trying to get thumbprints.
Vanessa, I just want to emphasize 150,000 words of Greek is, so if you analyze the last standing undergraduate reading list of Greek and Latin that comes from Yale, last one I know of, that has about 130,000 words of Greek and Latin. So this is more, and a PhD reading list aggregate would have about 1 million words of Greek and Latin. This is a lot of Greek. A lot more than you would ever imagine being able to read in a single semester.
Oh yeah, you couldn't read this in a semester, but I've done this in a couple of years, and I'm going to be doing even more in the future. I try to do an hour or two a day of tree banking when I can get it around my classes. But the point is you can see we've got a big hunk of Athenaeus now, but we can't really do much with him yet. We've got some Herodotus, some Thucydides, some Diodorus I'm working on, Thucydides I'm working on. I want to get more Plutarch. I want to get especially more late authors, because we're going to see a progression, I think. And then just a quick, Bridget just put some of mine up for that you can go to these sites and you can manipulate it but not save it, so you can see it. So anyway, I want to go quickly because I want to give Bob lots of time. Treebanking 101. Here's a very basic sentence from Diodorus. It's nothing fancy here. When you get this opened up in Arethusa, it looks like this. You've got sentence ID. You've got the URNCTS, so the ID for the author, the ID for the sentence, numbers. I can edit this text if there's problems with the scanning or something. And then you see there's places for lemma, post tag, and things like that. Nothing's filled in yet. I call it up in Arethusa, and you get a sentence list. Then you open up the individual sentence and you see you've got it across the top there. I've lost my mouse. Where is it? There it is. There it is. You got the sentence across the top. You see what number it is within the file. You've got the reference. You've got all these plugins. Color coding is amazingly helpful because it tells you what part of speech it is. You can't believe how helpful this is. These plugins allow you to do the morphological analysis, the relationship. You can add in words if you need to. So here's where I've actually hung the sentence. You hang it on the main verb of the sentence. We've got all these rules I'm not going to try to go into, right? But it's basically a grammar tree. You're just analyzing according to grammar. Use the morphology. As you can see here, I've got plain highlighted. I've got 4 choices. The choice I want is actually at the bottom because it's the infinitive here. So you can just go down, check that. You can add new forms if you need to. But this is a really amazing tool, and I can't say enough to the programmers for how well it works. It's a very simple set of labels. There aren't very many of them in the prog tag set. On the other hand, it's language, so it's incredibly complex. Sometimes you can translate very simply, but it's very hard to figure out how do you express this. But you think about language in a way you've never done before. Once you've got the tree hung, you can see we've got, for each word, we've got the lemma, we've got the syntactic analysis, you've got the relationship, and you've got it related to a word. So pole hanging on duname is the attribute of power, much power. Take that back in now. Now you see that the part of speech tag is filled in with the part of speech abbreviations. The lemma is there. What word it's hanging on is there as the head. And then the relationship, and that's where I want to draw your attention, the relationship. The relation is what you're going to be keying in on. You can add in words that are missing when you need it to complete the context. So the oldest sea battle was the sea battle of the Corinthians. I need that word again to make the tree make sense. Works very well, very nicely after much headache. You get very flat trees. You see just visually a lot of differences. You see these very flat trees, even though this is an extremely long sentence, clearly. It's not the longest I've seen, believe me. And you can get very deep trees showing a lot of subordination. So once we've got this whole database, which is going to be ongoing for a long time, what can you do with it? And that's where only the last few months we've been playing with it. And this is where I'm going to turn it over to Bob to let you know kind of what he's doing.
All right, thanks for that. I guess I should say why, we're trying to deal with questions of authorship attribution in a way. And why syntax? Why don't we just use the vocabulary, which is standard? Well, one of the problems is that in Athenaeus, he selects passages by subject matter. So all of the ones we've written about are about luxury and corruption. So they have, ipso facto, the same language in them. So we're not going to get anywhere with the scholar community by working on that. Something that it's obvious to everyone already. So we have to make an argument at a different level. And that's the level of syntax. And let's see if I can figure out how to do it. Okay. Now, we've seen already the database that we're working with. And so I'll remind you of the ancient Greek dependency set. But I won't look carefully at it. There are others out there. There's the Proyel set and something about Indo-European, whose initials I can't remember what they stand for. Pragmatic resources in Old Indo-European. A nice dependency data set, but I didn't use it. We didn't use it because there's slightly different tag set involved and a conversion level would be necessary. But they have, say, Herodotus. I think all of Herodotus or almost all of Herodotus done. They have biblical text done, and those would be very useful to put in. But I didn't want to just, for this presentation, deal with a different tag set, so I didn't. All right, Vanessa's already mentioned the kind of thing we have for each word. We have the dependency, the relationship, the lemma, the morphology, and the position in the sentence. So those are our basic elements. We've got more or less 5 bits of data that we can use, syntactically speaking. Now, there are all kinds of ways of handling them. How are we going to turn this into something we can analyze? And there are various ideas in the literature, and I've looked at them and played around with them. One is dependency distance. So to compute dependency distance, what you do is you find words that are adjacent in the dependency, like Lorraine and Ain, and you essentially just count the difference between their linear order, all right, how they occur. And then you calculate that number for each word in the sentence, you aggregate them, you average them, all kinds of things you can do with them, all right? But that's one kind of bit of information that one can use in this kind of analysis. Another is dependency degree. So I like this for some reasons. That is, a sentence with can have a high dependency degree if it has a lot of dependence off of a single node, and it has low dependency degree if it's linear. And I particularly like this because if a sentence has got a high degree, it's called a sentence with a high degree of hubbiness, and I like the word hubbiness. So, so that's I think an important aspect of sentence that will eventually fold into our analyses and our data. But I didn't do it for that for today. Interestingly, we find claims. One author says that a syntactic tree, of long sentences cannot have hubs. It categorically states that a long sentence can't have hubs because it would cause too much processing strain on your brain. But then I noticed sentences like this in Vanessa's set, and you can't see it very well, but it's a great long, I don't know where it comes from, these or someone. Looks like it has hubs to me, and it's long. A hub, as I say, is a node with more than one or two attachments hanging from it. So there's a research question already. Is this, these people don't base their analyses on ancient inflected languages. All right, but in any case, these kind of concepts are a little too abstract for me. I wanted to start with something that is more transparent, more human readable than dependency, distance, and so on. So I started with something that I found hinted at in various bits of the literature, which I've dubbed the syntax word, or sword, or pronounced sword for short. And you can see just a simple tree. Mary had a little lamb with the standard tags on it. And what one does is one reads up to make a syntax word from each word in the sentence, each leaf. You read up through the relationships until you get to the root. So these would be the syntax words for Mary had a little lamb. So Mary is a subspread root, or however you want to pronounce them. I don't have a system for pronouncing syntax words. But you see that you develop for each word in the sentence, or each token in the sentence, a representation of the syntax. All right, I don't, here I'm just going back to the kind of data that Vanessa talked about. You don't have to use relations. I use relations. You read back up the tree, and you can use whatever. Every time you intersect a node, you put down relation, or part of speech, or a lemma, or whatever it is you want. But the order is the order of dependency in the tree. All right. All right. Now I guess I'm talking. Now I have to go from the database to generating another database full of these swords, and I used xQuery just because I tried to learn Python, and it was going to take me too long. So I tried xQuery, and I found it very difficult to figure out exactly how to use it. But eventually, I got a very kind of kludgy script to work, and that's only part of it, which clearly should be made more elegant. But it worked. It took me quite a long time to write it, and what I end up is an output file that looks like that, more or less. And I just run every bit of the tree bank in there, and I get output that has my little swords in them, and that has the breakdown in this way. And here I took a random line from the database, old child Agamemnon, etc. And you can see that it starts with what we call an aux z, which is O, and then that is dependent on the ext, which happens to be the last word in this string, pi. So O is dependent on pi, which is dependent on the predicate that's off the screen, and so forth. And the next word in the sentence is an attribute of an attribute of an attribute, which hangs on pi. It goes through Agamemnon to Strategon to 2, and so forth. All right. So see how that is? The one generates these swords in this way. Okay. Oh, here's just another flavor. The same thing, but I haven't had a chance to work much on these, but this would be a combination of the relationship label and the part of speech tag. So then I just add part of speech tag at every step. So you can make these very complex. You can there's all kinds of flavors of this thing. Now, once I had this data, then we have to do something with it, and I used R for this. And at first, I used a general kind of machine learning package for R that was out there. R is a publicly available statistical program. It has a lot of nice prefab components that you can use. Well, I got in over my head pretty rapidly. I was getting great training data, like 100%, and then my testing data was like 0. I said, oh, I don't know what the heck's going on. So I backed up and I said, I'm only going to use algorithms I can actually understand, and that I can use on pencil and paper. I understand I had an overfitting problem. I now understand a little better, but I didn't know what was going on. I was happy, and then I wasn't. So for this presentation, I just decided, because I needed good data in a hurry, this was like January, February, and I decided I had to blow up my old data and start over, my old results. I just decided to use this stylo R package that the computational stylistic group had put together, because they've done some work with Flatman Greek, and it works pretty, I won't say easily, but at least it had enough stuff in there that I can understand that I thought I should go with it. All right, you probably know, most of you, that these kind of algorithms generally work, at least at some basis, with by relative frequency data. So the program goes through and counts every occurrence in the various files that I have it divided into of these swords, and it gives us a number for the relative frequency, and it uses these numbers to do its thing. I just thought I'd put it up there in case you didn't know that. Most of you know more about it than I do. And notice here we have, for example, aux k root, and I believe on the next one I put some means up there just so we could see it. Obviously, that's very frequent. Aux k root is the sentence punctuation. So that just tells us essentially the average length of a sentence in these authors. But you can see that Thucydides' sentences are much longer than Aeschylus's Agamemnon, for example, and so forth. So that's just by way of telling you what it does. And it uses this information then to produce this kind of dendrogram graph. Here we took the 500 most frequent swords, and we ran it into their system using the delta, which I'll talk about very briefly later. But delta is actually something that I can do with pencil and paper, which is why I like it. I can understand it. It's not too confusing. So here is a cluster analysis, which is basically unsupervised in the sense that you tell the machine, here's a bunch of information, put it into groups using your method. And, I don't suggest what the group should be. And you can see that it's pretty good, right? We have a split early between poetry and prose. We have drama and and other kind of epic poetry splits out early, so that's useful. I mean, basically just on syntax alone. We have historiography splitting off from oratory, Plato kind of in the middle there. We have Athenaeus together as closely as it could be. We have Herodotus and Thucydides next to each other, as best I can see. But we do have a bit of oddity going on here. We have Ajax has wandered away from where he belongs and is among the Aeschylean works. But my feeling is from here that there's enough to be going forward with. But I say, what's wrong with that Ajax? And then I tweak. So I look back again and I say, well, maybe what we're getting here is all just a reflection of sentence length. So what I decided to do is just ignore the first 10 of these, which are, many of them are proxies for sentence length. And I go on, and I get another bit. And Ajax is still astray, and somebody else has gone, if I remember. Oh, the Persians has gone to join the Hesiod. Okay. Well, and then I looked a little more carefully and said, well, these are problems. You have to say, what's going on? But I realized that the Ajax has been annotated by someone different than did the rest of the Sophocles. I said, okay, that might explain it. And we have to deal with inner annotator discrepancy problems, and that's something one will have to deal with. We'll have to handle that. But, just a funny story was, when first time I did this, the Agamemnon was way off. It was like the most different of any of these things. And I think, well, I can barely read the Agamemnon, so syntactically, I thought maybe that's plausible. But then I found out it was just a circular, there was a circular tree within the Agamemnon. That is, link 5 is dependent on 6, which is dependent on word 7, which is dependent on 8, which is dependent on 5, which is not supposed to be able to happen, according to the software. And this caused my little script to blow up, essentially. And so I had just reams of gibberish in my code sword bank. And so, there could be an underlying problem in the coding that handles some of this. All right. So anyway, I won't go into this. Is just the algorithm that is behind it, but it basically is very simple. You can do it in a spreadsheet. You can do it with a pencil and paper. So I just demonstrate here that it's one of these transparent algorithms, which is why I started with it. And we can talk about it later. And I was talking to Frederick the other day, and there are better ways of doing it, but this I started because I could understand it. Eventually what you get from running these things is a kind of a distance table. And it reduces the whole of the comparison of the similarity and difference between two texts into a number, a single number, the algorithm does. And then it builds a distance table like this, and you can then see that some works are closer to others. Obviously, the Agamemnon is as close to itself as it could be, and so on. So that I just showing you something going on under the hood, as it were. And it uses these numbers to cluster, as we've seen before. All right. I will. Now, one of the things I like about this package that I use is it continually can give us interesting human-readable data. And so it has a feature oppose, and it tells us, I don't remember which authors these graph has to do with, but it can say these words are the words most avoided. These syntactic structures are most avoided by the given author set, and these are the ones most used by the given author set. All right. So one can get this kind of a very simple calculation. Again, I use it because I can do this with pencil and paper and figure it out. And it gives us immediate data for our students, for example, to say, okay, this is supposedly Thucydides' favorite structure. Go find it. Go tell me. Talk about it. Write a paper. And here's the way the thing is figured. As I said, you just divide your text A into segments of, say, 1,000 words, and then you count the number of hits, and you divide them by the number of segments, and then you count your other comparison text B into equally sized chunks, count misses, assign them each a -1, count them, divide. And that seems to be a good system. And you get this kind of thing. And as I say, you get some results that are immediately analyzable. So this is one of Thucydides, as far as now we're talking Thucydides insofar as we've been able to analyze it. We've only got 3/4 of the book or something. So, this is one of his favorite constructions. Adverb co-coord, auxi, predco. And I've got the words underlined and we follow it up. If X and Y, then A and B. Okay. So it says, if they came and did something, then they took. But so you can't really translate these things easily. They're abstract structures in a way. But you can see that now we know just from this intermediate step, we may know something about Thucydides that we didn't know before. So that's one of the reasons I like these things. How are we doing in time? 15 minutes?
Almost, yeah.
Okay, I'll run through these, but I have quite a few of them. This is the same structure as before, and of course it looks, in the instantiation, looks quite different. So you have to get used to thinking of abstract syntactic structures, because we have a cause clause instead of an if clause, and so forth. We have our element coming after the coordination rather than before. But again, we have suddenly new information about our authors. Yes.
Do we have enough data here, so that we can express our confidence about the significance of the of this frequency, of this preference?
The system is supposed to check for significance. I don't know how significant that significant check is, given the size of the data. So, my math isn't good enough to know. But that is a problem, right? And I would say at this stage, don't bet on it in Thucydides. But I did check, and I'll show you the Homeric text against everything else. I think that should be significant.
This is amazing. I mean, it's amazing. I mean, it's like, even if the numbers are small enough so that it's not statistically significant yet, the fact is, it's going to be statistically significant for these big prose authors.
This is one of these things. When he first ran this, he came and woke me up in the middle of the night to show it to me.
So because it's cool. Yeah, and I get in trouble for these things. So it must be important. You're going to risk that kind of thing. All you young single fellows out there, let me tell you. That's something you should do lightly. So I just I won't run through these all. But I have a whole set of them, and some of them are quite fascinating, and some of them I don't know how to think about them. But you give them to students. You say, do something with this. You can see.
Positives.
Yeah, positives. Herodotus, we have some. And Polybius. And they do change quite radically.
Well, for example, you see here, Polybius loves to coordinate participles in the nominative, which other authors don't do as often.
Right.
He's far much bigger at coordinating.
And one of the problems is to take the top 10 structures that Thucydides like and abstract the commonalities and then talk about those. Or
and what does he avoid is the next question.
It seems to me that one of Polybius, I think here, he loves stacked coordinators. And I find that, at least in some later literature, I once had in Cicero's De Finibus 6 stacked coordinators before I hit a single content word. So you can't even get your mind around it.
But here, I mean, again, you've done the abstraction. You've inferred the fact, decided that chi and de are both coordinators, and thus you have this pattern. And you could argue, you could run it again with lexical entries if you wanted to compare it. But that's a level of abstraction generalization that gives you a view that you would not otherwise have.
Right. I think it's good. I just spent hours contemplating. One, I want to slow down on. This is, I think, as I recall, something that Homer doesn't like. So it gives you a list of things. And I looked at the whole list of 20 things that Homer really avoids. And, he really doesn't like subject verbs of a prayer that have their own subjects or objects. So this says, it was not seemly that the people, the soldiers, gather these things. So this, I would never have guessed that this is something that according to the data, Homer doesn't like. But this is very easy for an undergraduate to get their teeth into and to do some work. And tell me, is that a feature of Homeric style? And when is it no longer? Because it's extremely common apparently in other Greek, but Homer unusually avoids it. So anyway, you can see why I like this kind of sword analysis, because you get useful data at the intermediate steps, as opposed to, say, dependency distance, where you get numbers, which I can't do anything with, but I can do something with this. All right, I think, let's see, where am I? All right, back to what we were talking about with our authorship attribution problem. And after one does these kind of clustering things, then one tries, according to the books that I read, one tries supervised attempts. You basically have a set of training data, and you feed into your algorithm, and from it develops a pattern. It tries to identify the signal for each individual author, and then you take some test data and you put it in, and you come up with that. And that's useful because the same people I took the program from have done some work on this using lexical data. So I said I can compare lexical data to syntactic data and see what we come up with using more or less the same approach. This is their data, basically showing that as the length of the passage shortens, you get degradation in the accuracy of the performance. And this is important to us because the passages we're eventually going to look at and analyze are quite short. A couple hundred words would be a long passage, probably. And so we're looking for something that's robust with respect to length. And we haven't got there yet, but we're on the way, I think. And the problem we're dealing with is not quite as difficult as absolute authorship attribution. But in any case, feeding in the syntax, this I followed more or less the same protocol, and this is what I get, which essentially is more or less the same curve. So from which we say that syntax data is just simply derived in the way I've done so, is as strong as lexical data for telling an author from another with respect to length of passage.
Have you tried combining the two to see if you get the combination of the two signals gives you more power, so you get more discriminative? You can do more with shorter passages.
Well, I wouldn't do that directly because we really want to avoid the dilemma in our work, because they're all the same. The passages in F and IS are always.
Yeah.
But in general, yeah, I think combination. There's dozens of different ways I could have done it. Yeah, I haven't even, yeah. And combining the part of speech might make a difference. And here's just the numerical estimation of my output. So when you put in passages of 2,500 swords, you get a mean rate of about 80% and so on, which is all nice, and so forth. And you can see it falls to 41%. And about the time I get to 200, my computer bogs down, doesn't want to do it anymore. So I suppose there are tricks that I don't know to handle so many different segments, but there you go. So that's in a nutshell, and I know I've gone really fast and skipped over things, what we've been doing, and it looks profitable. It looks like it's worth following this up. And so what do? Yeah, we have to keep trying every possible test that we can think of.
There really are dozens and dozens of ways one could search this.
There are many flavors. I mean, the n-gram of these things is going to be something we obviously have to check. I mean, how? Because I'm pretty sure that in given offers, the combination, the linear order in which these syntactical nonlinear elements occur is going to be very, very important. And I haven't even factored that in yet, but we can do n-grams of these things. We can add parts of speech. Dependency distance, I think, is going to be worth adding, because I've just noticed, maybe I went through it too fast, that in Thucydides, there tends to be at least one node in some of these common swords that's really far apart linearly, whereas in Herodotus, they tend to come together. And so that has to be put in to the code somehow. And of course, there's many ways of computing these things. I started out using support vector machine because it sounds cool. And, everyone was using it in the internet. Said, "Oh, I better do that." And then, of course, that's when I couldn't understand the output, and I just said, "No, I need something you can do on a pencil and a paper." So I went back. Oops, looks like I got a duplicate slide. No, that's the same thing. Also, I want to aim directly at the research question. And what I have in mind is, like Vanessa said, we need to take an author like Theopompus, who's well represented in Athenaeus, and do the tree for all of the fragments. And that way, test this time to see whether we can distinguish transmitting source based on syntactic information. Focus on that. So what do we need? Well, we need trees, of course. So any of you who are interested in doing trees, do trees. Please do trees. We like them. The more we have, the better our data is. Also, metadata. And we're working on that right now in the various from the various ends. I need to figure out how to scale the workflow. When I was putting these slides together, we were trying to come up with those sentences. I basically had to work back through which are the common Thucydidean structures. I started with the output of R, open X query output, and search by hand for the thing, and then open up an XML file with the tree in it and search. So I mean, this is something we all know. We need stable word by word identifiers so that I can go so I can have the metadata associated with the R file and instantly go between the output and the tree that it started from. Everyone in here knows this better than I, but it does cause trouble. Oh yes, the vision thing. What I'd love to see and be part of working on is incorporating syntactic data in our work as we go forward. So when you're doing trees, it would be nice if you could pull, if you do an annotation, you could say, is this a plausible annotation, Mr. Computer, or Ms. Computer? And they would come back with yes, no, and so forth. So real-time or close to real-time feedback for annotators. And the same kind of thing for readers and users who aren't interested in the tree. But you can pull these kind of analyses in as many different ways when you're reading a text. What is the language like compared to language in the same period? What is the rhythmic structure like, and so on. All right, that's all I have for you. So thank you for listening. I hope it wasn't too disorganized. We were running pretty fast. I'm sure Vanessa will entertain questions if there are any.
I have one for you.
Yes.
So you described the process of deciding to eliminate some features because you suspected that it was just correlated with sentence length,
Mm-hmm.
and that kind of approach to adjusting the dimensionality of your feature space might work fine, just through trial and error. But I wondered if you considered running something like principal components analysis over that, just to see if you could detect whether a few of the features are accounting for a large amount of the variability.
I did consider it, but I just don't understand
This is
it.
where the word collaboration becomes important. I keep arguing we need more, some programmer deeply involved in this, and he keeps wanting to learn it himself. And I think it would be more profitable if we get more people involved that know more about the programs.
Yeah, you're right.
Because we are, at the end, pure, poor dumb humanists here.
Clearly, what we want to know is what part of this data set is influential and what is just duplicating the earlier. So principal component analysis, I think, would be the right. But you're doing that if I understand.
Yeah, I mean, if they have dependencies among your features, because the S words themselves are going to stand in ultrametric distances within a sentence to each other, right? So over the move of the author, I can't imagine that there wouldn't be correlations among them. So, but even just in terms of getting a sense of, are you missing something obvious that might even have a pretty reasonable interpretation, like sentence length? You might be able to discover something like that in a
Yeah, it would be very important to know. And as I like, the nice thing about this is as soon as you discover something, you can think about it in grammatical and syntactic terms because that's how the data is set up. I think Thomas had.
Yeah, I actually have a couple of questions.
Oh, Thomas, now.
That's many questions. I hope you can answer. Do you have any idea how many unique semantic structures in your corpus exist?
Yeah, I did, and I did, but I do have that data somewhere. I can't take it off the top of my head.
You don't know.
Off the top of my head, no, because I have too many numbers of them.
Well, if it's not too many, then it would be a way of restructuring our grammars, semantics, and just explaining what actually occurs instead of the other rubbish that is not.
Right. I mean, the type token ratio or whatever it is. Yeah, I did compute them at one time, but I couldn't think about whether they were very valuable, so I just let them go.
I need to point out that we've only been, he's been getting some results for a couple of months now, so this is just scratching the surface of what will go on for decades.
I assume so. That's why I didn't expect that you can answer any of the questions now. Maybe
well, then go ahead and ask them.
The other thing is, if you have this number for the author, how many unique structures an author uses could also be a way of differentiating the authors.
Yeah.
Yes.
Maybe in combination with what is the deepest level? So how long is the longest?
Well, I guess what
maybe then an average for that term could also happen.
Yeah, I mean, what I forgot to say is that obviously this is all meant to be public data, and so I would find the appropriate place on GitHub or whatever and put all my output files and my scripts on there and say, take care of them, like, do something smart with them. Yeah, I can.
And I have to ask this question, and you will probably hate me.
Oh, it's up to you.
How often was punctuation actually decided in the unique structure?
Yeah, I don't know the answer, but yeah, there is a case where punctuation will be. I don't think it ever occurred in the top 15 words avoided and words preferred, but punctuation is in there. And not to mention the question of ellipsis, which we. So that's kind of a creation of the annotator and a completely, we've had these discussions.
Yeah.
And so that could cause trouble. Also, there's all kinds of factors in here, like we changed the system a little bit in the middle, right? So we used to do ellipses one way, and now we do it another way. We're going to have to handle that in this analysis. I'm going to have to. But fortunately, Vanessa's been doing most of the prose. So when we come to Athenias, we can just restrict, because we can restrict our data sets to prose, and so we eliminate some of just the fact that we used to do ellipses one way and now we do it another way. Yeah. That's gonna separate clusters artificially that way, right? Yeah. It's going to be artificial then, but I didn't have time to deal with that, and I'm not sure how to deal with it. So, other things? Yes.
So a comment on your point about the kind of like using the fifth floor or long tail of distribution. You do have a problem with data sparseness when you too much depend on by using unique or very infrequent features.
I wasn't referring to SIFs. It was just.
And right, but I think you were kind of talking about what recently been called the long tail, like the big number of very
I mean, SIF goes. SIF also is mainly correct for the occurrences of words. So I wonder if you can just transfer it to the occurrences of the structure.
Exactly. I mean, that's something that I also would be curious about to see the distribution of these.
Speaking of the long tail, I mean, I didn't know that's when you're using the n-gram, right? You suddenly flatten and lengthen the curve tremendously. But I don't know whether that's good or bad a priori. So I didn't start with n-grams because suddenly you get so many more possibilities that each one of them repeats so many fewer times. How does that make it? Ultimately, my goal is to be dealing with short passages. So that's one reason I eliminated, for example, length of sentence, because the author that I'm looking at Athenias probably truncates things, and so sentence length is not going to be a usable feature. So I was worried about, I could get n-grams, but that would make the tails extremely long, if I understand this, because we'd have lots of things that only occur once.
Yes, but then you might actually also have more unique features per author, and thus a better chance of getting a hit in any.
Yes, and this is why I need someone who knows about such things to tell me, because I didn't know how to get the answer.
Well, that's also just a wild guess, really.
Yeah.
I haven't given it.
Now it's your wild guess.
I have two more points. So I'm just assuming that you are aware, excuse me, but that you are aware of Van Halteren.
Probably not, no. Don't worry, I always insult people I talk to. It's part of my method.
Because he's kind of been called a madman for the range of features he's using for authorship attribution, but somehow it works, and so that's just to recall that the most unlikely things might work in the end. It would be interesting again to try to understand why they go.
It's very clear that we don't want to eliminate things if we don't have to. I mean, there's, like I say, there are just so many different ways you can approach this, and once the data is out there, other people will do things we never thought of.
And the research question is not one of author identification, but giving us almost a similarity and difference in rating, because we already have an author attribution from Athenias. We're just wanting to gauge, has he changed anything when we don't have the original? So it's not quite the same. We don't need an absolute category A or category B. We almost need a spectrum. Which texts in the corpus are this fragment most similar to and most different from, and give us a rating, and we can look at them and we can do some philology and some argument on that basis.
Right, which leads me to the third point, the pollution by using different annotators. And so my first intuition would be to take a hit at that with hidden Markov models, because they are commonly used to kind of separate an event from its cause. And thus, there might be a chance that we'd be able to separate the annotation from both the author and the annotator. I don't know exactly how that, it's been a while since I've worked with that, but that's just the first idea that comes to mind. Maybe there are even better methods nowadays. But there's definitely tools to try to do that.
My answer is yes. Thank you. Yes.
One other suggestion. This is a deeper one, and I think it really is for humanists, not for statisticians. And that is that you alluded again, just sort of as an aside, to the fact that when you are computing any metric distance, any particular author will be zero distance on itself. And in fact, as an artifact of the way that the math is done, points in your model are going to satisfy all of the metric axioms, not just zero distance from themselves, but distances will be symmetric and they'll also respect the triangle inequality. Certainly, any dendrogram, the ultrametric tree, and any points arranged on a plane are going to satisfy those. Just you can't get around that. But in many applications, the underlying sources of variability, the qualitative empirical relations that we really care about, that are kind of driving that data need not respect the metric axioms. So I can give you examples of where that comes up in other domains like bibliometric mapping of disciplines. But they sort of correspond to what psychologists like Amos Tversky have told us about human similarity judgments failing to respect those axioms, like the way that we consider to be Taiwan more similar to China than China is to Taiwan. So if you have something going on, like one author's grammatical style being influenced by an earlier author that he or she has read, then that's an example of something that's not symmetric.
Okay.
And so I think I'd invite you to sort of try to think deeply about what are the empirical relations that you care about, and when placing points within an ultrametric or Euclidean model where the metric axioms are sort of enforced might be distorting the view of things. You can detect when that might be happening in scaling and clustering methods that give you a goodness of fit, where forcing it into a tree or forcing it onto a plane just means that you've lost a certain amount of information and it comes up with the best fit that it possibly can. You get a measure of that. But interpreting it right, that's something that no statistician can do for you. They can't get at, because you're the experts in what you think is really going on there.
Okay.
I also want to mention, I mean, there's also broader stylistic questions about changes in Greek syntax over the ages, about influence of Latin upon Greek or Greek upon Latin. I mean, there's going to be all kinds of other things that can spring out of this. I mean, my immediate question is this historiographical question, but that's just scratching the surface of what the possibilities are. Like I say, I mean, I could see thousands of, projects being spawned in different directions. You just have to think creatively about this kind of information and what's available in trees in general and in other data banks, but with this open source, that's the goal. I mean, this could open up a whole new interest in syntactic analysis and like I say, just the ability of, okay, here's a pattern, let's see what it looks like. This is the typical Herodotean sentence as opposed to the typical Polybian sentence. Even the pedagogical uses are really impressive. So there's all kinds of possibilities, not only for searching, but also for taking this in different directions.
We're going to have to finish up in a minute or two, but I wanted to ask so one opportunity, and driven by a PhD student, my student Saeed Majidi, trying to finish his PhD in exile in Iran, exile from the US as far as I can tell, and get back in, would be to take your samples, and he's got 3 syntactic parsers that work off training data. You give them a bunch of examples, they generate a parser, and they go off and analyze everything else. And it would be interesting to see what kind of, first of all, what is the precision of the automatic stuff you get with 20,000 words analyzed or 10,000 words analyzed. You go the rest of Herodotus, Thucydides, Polybius. And then secondly, irrespective of the error rate, how effective is the data that you generate in actually answering the questions that you want? Because even noisy data can be very useful if the noise is distributed randomly and the signal is preserved. And you can test that. And you have enough stuff now where you could actually, you have enough of a handle of what you're doing that you can start to see, well, what happens now if I look at all million words of Plutarch, or all 150,000 words of Thucydides? Do I get more information? Is my sample good enough? There's a chapter, there's a publication that would have 2 different instantiations, one for computer science, one in the humanities context. That would be very helpful in this in this as well. And you have access to this guy who's got, who's done this work. One more question, or?
Yes. All right.
Only to repeat your initial statement, now we can begin the study of Latin.
Yeah.
Now that I'm old. We all are.
All right.
Well, thank you.
I'm just going to do a bit of a PSA. To anyone watching the Hangout, thank you so much. We did have an issue with the slides. So PowerPoint slides will, with your permission, be posted online at the Perseus blog.
They didn't go through?
No, we encountered this, one second.
Not remembering my high school stats.
Oh, you know what?